Hello students and viewers. Today we will discuss the chapter wireless sensor network in context of Internet of Things. So wireless sensor network, if we want to study, we will start from a future of the WSN from that. So let us see. All of you may have seen this kind of interface in your mobile or laptop. What it is representing? It is basically representing some cab booking app. Okay, and in such apps we see the presence of the different vehicles nearby in the map. Okay, and from there we can choose, or in some case automatically we can get the cabs for booking. Now next is this picture is also known to us now. This is representing a driverless car. Okay, now how this driverless car works? Basically this car works with the use of a lot of sensors and cameras installed inside it. Now if I combine these two technologies, like, so the driverless car, it is the ultimate example of the automation, that a car will drive on the road without the human interface. So if I see now, if I want to get a particular application where nowadays we also book the cab from the different applications, and those vehicles are coming to us or being served to us by the drivers. But if I can imagine the days when the cab will automatically come without the driver, so that can be possible by the application of the wireless sensor networks, where these cars are being these cars are being used as a combination of lot of sensor arrays. Okay, and those are capable to help the car to be driven without any human on the road. Okay, and that also we can select our starting point, we can select our destination, the car will come and pick up us and send us or reach us to the destination. Okay, so this is this can be the future application of the wireless sensor network. But now, till now, where is the wireless sensor network existing? Let us see that. Okay, so first we start with what is the wireless sensor network. So basically it is consisting of a large number of sensor nodes which are deployed over an area. Okay, now these sensor nodes are capable to communicate with each other, share data with each other. Okay, and what type of data? So nowadays we can have the wireless sensor network for the weather monitoring or monitoring the environmental conditions. Okay, so for that, what type of data are being sensed? Like that light, temperature, sound, vibration, this kind of data can be sensed. Okay, and the sensed measurements are then transformed into some digital signal, and they are stored locally, and also from a particular node they can be sent to some other sensor node. Okay, now this communication can be made among few thousand to few sensor node can be connected to each other in a particular network. Okay, and now how the communication basically works? The communication are based on the radio transmission. Okay, and where the path is something like a multi-hop path. Multi-hop path means what? We can give the idea from this particular picture. So in this picture we can have a several number of sensor nodes which are deployed in a particular area, and these sensor nodes are having transceiver facility. Transceiver means it can transmit the data as well as sense the data or receive the data. So I can see, so here it is in this diagram, this particular node is working as a sync node where different nodes data are being collected, and from there here it is the base station. Okay, so in the base station the data is being stored. Okay, so here the data is being stored. So what data is being stored? The data being stored, that is the sensed by the different sensor node, and from this here I can see that from this particular node the data is not directly sent over here. Okay, this is not done. It is sent to the nearby sensor node, and from here it goes to another sensor node, from here it goes to another sensor node. That is, every sensor node is sending data to its nearest another sensor node. Okay, so this is called the multi-hop communication. Okay, so it is not a direct communication from here to here, but it is a multi-hop. Now what is the advantage of taking this multi-hop? The thing is that if some sensor which is present over here that want to send the data directly to the base station, the transmission means the energy required to transmit this particular signal to a very large distance will be very high. Okay, and therefore this particular sensor node have to consume a large amount of power. Okay, so this is the problem, because here when I will discuss about the construction of this particular sensor nodes, there we will find what is the problem behind this. Now the thing is that for now we can see that the communication mode that is used, that is a multi-hop path. Okay, now you see every sensor node is having different parts inside it. So here we have given the block diagram of the sensor nodes. Okay, so in next page let us see. Here I have given the block diagram of the sensor node properly. So here I can see there are several parts. What are the main parts? The main parts are the sensor, which is the sensing unit, and the sensor is consisting of not only the sensing unit but also it is the having ADC, that is the analog to digital converter. And next there is a processor and a storage, together we call them processing unit, and there is a transceiver. So these three are the elementary or essential blocks of a sensor node, and to give them power there must be a power unit. Okay, so these are the essential parts. Apart from that we have some additional part which may be present in some sensor node, or in some sensor node they may not be present. So that kind of that blocks are the location finding system and the mobilizer. So what is the necessity of these different blocks? Let us consider, let us discuss them one by one. Okay, so here I can see the practical picture of some of the sensor nodes. So here I can see this particular sensor node. This is used for some soil data collection in fields, and that is having some antenna which is used for the transmission and the reception. And here in this particular sensor node I can see there is a solar panel. Okay, there is a solar panel associated with it. So basically this gives the self-generation facility, that is the power self-generation. Okay, so this is the power generator. Okay, so this power generator is also a optional part. In some sensor node they may present, or in some case they may not be present. Okay, so it is the it is having in this picture the sensor node which you can see, that is having the power generator as well. Now let us see what are the function of the different parts of the sensor node. The first one is the sensing unit. So all of us we know that the sensing unit is the basic part of any measurement. Okay, so to make any kind of measurement, the first thing we have to do is to sense that particular parameter, sense the change which has occurred in that particular parameter. Okay, so for that the sensors are required. Okay, so in the sensor node also we have that kind of sensors. Okay, so they are used to capture the data from the environment. Okay, it is usually composed of two subunits, that is the sensors and the analog to digital converter. The sensors produce the sensor takes the measurement from the environment, and that is it senses any kind of change in the physical parameter of the environment and convert it into some signal. Okay, and from that signal it is required to be stored in the memory, and therefore they require to be converted into the digital form. So therefore from the sensor data, that is from the sensor signal, we have to convert it into the digital data. So therefore the sensing part must be accompanied with the ADC, that is the analog to digital converter. Okay, the sensors can be classified into three categories. Okay, so now this is one important thing, that is the classification of the sensors. Okay, so what are the categories? The first one is the passive omnidirectional sensor, then the passive narrow beam sensor, and then the active sensor. Okay, so the thing is that when we have studied about the basic course of the sensors and transducer, there we have learned that what is the definition of the active sensor and the passive sensor. Okay, so in that course we have studied that the active sensors means they are the self-generating transducers, like the thermocouple, the piezoelectric, they are considered as a active transducers. And what is the passive? Passive means there some other energy source is required, like if I consider about the RTD can give us if the temperature changes, RTD's resistance will change, but to measure that change in resistance I have to give some external power supply to get how much resistance has been changed. Okay, so that is in passive sensor. So that idea we have got in the course of the sensors and transducers, but now the idea is a little bit different. While I am defining the active sensor and the passive sensor in terms of in the course of the wireless sensor networks, here we can see that the passive sensors are called the self-powered. Okay, the passive sensors are the self-powered. They senses data without actually manipulating the environment. Means here from the environment, in the environment they are not emitting any type of energy, or they are not taking any kind of energy from the environment. Okay, so without manipulating the environment they can sense, therefore they are called the passive sensors. Okay, and they require the energy only for amplification, so they can generate the output by their own, but if I want to get the amplification of that output, then I have to use the external energy sources. Okay, and what is the active sensor? Active sensors actively probe the environment. Okay, so for example, what is that? The sonar, radar. Sonar is what? Sonar, they are emitting some sound waves. The radar, they emits the radio waves. Okay, the sonic beams, radio waves. So these kind of beams are being emitted in the environment to sense some other parameter. Okay, so therefore this kind of sensor, it is considered that they are actively probing into the environment. They are emitting some energy to the environment. Okay, so that is why they are called the active sensors. Okay, so in these cases the external power supply is always required. Okay, like if I consider about the ultrasonic transducers, so that is also in this case, as per this concept, I can say in the ultrasonic transducer I have to always give some energy so that the ultrasonic sensor emits the ultrasound waves, and it can detect the existence of some other obstruction in front of them. Okay, so therefore these kind of sensors are considered to be the active sensors. And among these, another thing is that it is the passive omnidirectional. Omnidirectional means what? It is not having means any particular sense of the direction. It can sense from a wide angle of the environment. Okay, and narrow beam means what? Here a pointed direction is there, means like a camera. Okay, here if I want to sense the multimedia information from the environment using the camera is faced at a particular direction, and from that direction only I can sense the information, I can get the information. Okay, so this is basically having a particular narrow beam, means a particular direction sense has to be there. Okay, so omnidirectional sensors have no direction of notion in their measurement. So if it is the omnidirectional, in that case no directional notion is there, but if it is the narrow beam, here there is a importance of the direction as well. Okay, next is the processing unit. So in the block diagram we have seen, it is another essential part of the sensor node. So the data that is being sensed by the sensor, it is initially sent to the processing unit, which is present inside the sensor node for further analysis. Okay, so some sort of analysis and information extraction is possible by the processor which is present inside the sensor node. Okay, now what type of processor is useful for the sensor node? So basically microcontrollers are most useful processor for the sensor node because of their some properties, like their low cost, flexibility to connect with other devices, ease of programming, and low power consumption. Okay, so this makes the microcontrollers the best processor for the sensor node. Apart from that, some other processors like the alternative part is the general purpose desktop microprocessor, digital signal processing processor, okay, DSP processors. So these are also used in some of the sensor nodes. And obviously whenever there is a processor is used to process the data, the first step is that the data has to be stored in some place. So therefore there must be a memory. Okay, so that memory can be of different types. Okay, so from the energy perspective, the most relevant kind of memory are the on-chip memory of the microcontroller and the flash memory. So we have already told you that the energy consumption is one of the important aspects for the sensor nodes. Okay, so therefore we have to think about the memory which uses less power. Okay, so therefore the inbuilt memory of the microcontroller is used for the storing of the programs. Okay, now two categories of memory based on the purpose of storage are there. So there are two type of memory. One is the user memory and another one is the program memory. Okay, so user memory is used for storing the application related to the particular extraction of the data or processing of the data and some personal data. Okay, and the program memory is doing her program memory for programming the device. It also contains identification data of the device if present. Means what? I have told that in a particular network there are 100 to 1000 number of sensor nodes can be present. Okay, so therefore these sensor nodes must have some identification number or tag number type of things. Okay, so that information is also stored in the program memory, as well as the different programs which are required for the processing of the data and then storing it and transmit it whenever required. So that programs are stored in the program memory. Okay, the next thing is the power source. So about the power source we have already discussed that what is the requirement of the power source. The power source are required for all the other blocks to run smoothly. Okay, now in some of the cases for sensing also the power is required, and for the transmission of the data there also power required, and for processing the data the processor has also required the power supply. Okay, but among these three the transmitter requires the maximum amount of power. So the battery which is given to a particular sensor node, the maximum power of that is being consumed while transmitting the data. Okay, so therefore we have to take care about that when the data has to be transmitted and to which distance the data has to be transmitted. So that I have talked in the first slides also, while I have discussed about the multi-hop path. There I have told that the multi-hop path is used so that the data is to be transmitted to the nearby node. Okay, not to the farthest node where the sink is present, where the data is ultimately stored in the server. If I want to directly send from a particular node to the destination, that is to the sink, then we have to increase the power of the signal that is being transmitted. Okay, so that is not desirable. Okay, so therefore we use each and every node in such a way that from one node to other node the data will be sent, and from there the data will be then passed to the other node. Okay, so this is how we can reduce the total power consumption by using the multi-hop path. Okay, now what type of power source is used? Normally the power is stored either in battery or the supercapacitors. Okay, the batteries can be both type of chargeable or non-rechargeable. Okay, and in some of the sensor node the power generation facilities are also there, that I have already shown in the picture, that we can use some solar cells, we can use some piezoelectric or some Seebeck effect type of material, means energy source. Okay, where from the temperature difference, okay, from the solar resources, from the vibrations, the energy can be generated. Okay, and those energy is used as for charging the battery, and from there the energy is being supplied to the different parts of the sensor node. Okay, so next is the application. So what are the different application area of the WSN? We can see the sensor nodes can be used for the temperature measurement, humidity level measurement, lighting condition, air pressure, soil makeup, noise level, vibration. A large number of quantities can be measured from the different sensor nodes, and the application area of the wireless sensor network are basically in the surveillance, the monitoring of the soil condition, monitoring of the environmental condition. Okay, here I can see the soil sensor node. So here the different parameters of the soil is being continuously measured, and that data is being sent through the transmitter to the server. Here it shows the temperature flux sensor node. So what is doing? It is sensing the temperature, environmental temperature. Okay, it is the weather sensor node. Here the different type of weather monitoring sensors are there, like the for the wind speed measurement some sensor is there, some rainfall measurement sensor is there, air pressure measurements purpose sensor is there. Okay, so different kind of sensors are accumulated together in a single node, and from there the generated data is being sent to the server. Okay, so this is how using the different sensors we can take the data from the different points of the particular area under observation, and that data is sent to the server. Okay, so basically the wireless sensor network, the total thing is being used for the collection of the data. Okay, and from there by analyzing the data we can provide the different type of service, like the in the healthcare sector also we can use the WSN, we can use the WSN in the agricultural sector, we can use it for the security purpose, for the surveillance purpose. Okay, so and also the first example that we have shown, the in the logistics, in the automotive sector, there also we can use the WSN. Okay, so next is we have talked about the different type of sensor nodes. Okay, now let us see what are the mode of detection. So basically the sensors are used for detecting the different parameters in the environments. Okay, now if I consider about a particular application of the particular WSN, I have to know what are the different modes of detection. Okay, so here we can find there are 4 mode of detection. What are those? They are called single source single object detection, single source multiple object detection, multiple source single object detection, and multiple source multiple object detection. So how they are working? So in this particular picture I can see it is the example of the single source single object detection. What is there? In this particular area a large number of sensor nodes are deployed. We can see starting from 1, 2, 3, we can get up to 18 number of sensor nodes are deployed in this particular area, and from them there is a particular sensor which is called numbered as 17. This 17 number sensor is detecting one object. What is that object? That object is a human. Okay, so here the one sensor, that is the one source, is detecting only one object. Okay, and that information is sent to the sync, that is the 14th number of sensor node. So this one is used as a sync, and this is representing that this from here the user is getting the data. Okay, so this from the number 14 the user is getting the data. So the 17th sensor node have identified one object, that is a human. That information is being sent to the user. Okay, so this is called the single source single object detection. Okay, next is single source multiple object. Here we can see that this 17th sensor node, this is detecting 3 objects, that is one human, one vehicle, and one building, B for building. Okay, so here the same sensor can detect the multiple objects. Okay, and the information is sent to the user. So this mode is called single source multiple object detection. Okay, next one, it is the multiple source single object. Here we can see the same object, that is one vehicle, but it is being detected by all the 1, 2, 4, 15, 17. All the sensor nodes are detecting only one object, that is this car. Okay, so this is the multiple source single object detection. And next one, this is the multiple source multiple object detection. Here we can see that there are this 1, 2, 4, 17 and 9. All the sensor nodes are sensing different objects, and here we can see that this 17th node can sense the human, that is this is one object, whereas this node number 2 that senses the vehicle, but this node number 4 it can sense the building as well as the vehicle. So here from the different sources we can get the information about the different objects. Okay, so this is called multiple source multiple object detection. Okay, so these are the 4 modes of detection which are used in the wireless sensor networks. Okay, so for now let us end our lecture today. So these are the references from where we have gathered the informations. So for now, thank you.